Hi, hello, welcome. So in this video, we'll solve right rotate the array by one index problem. So let's understand what is a problem statement is. So there will be given an array of integer type. So you need to rotate its element by ones from the right to left. So let's understand with an input. So there is an input array 1, 2, 3, 4, 5. When we do a rotate one element, so which is last element, which is the right element. When we do a rotate, so the 5 will come to a first element, 5 will come to a first position. All the subsequent elements need to move to one step ahead. So this will be a sample output once we do a one right rotate. So this is how it should be. So 5, 1, 2, 3, 4. So this is the first elements which was there. And when we done the one right rotate, so the last element which is 5 will be moved to a first element, and then all the element will be one step ahead. It will be moving. So this is what the sample output is. So now how do we solve this? So let's understand the solution. So when we look at the code, so we have a main method and we have an input array. So which we already seen 1, 2, 3, 4, 5 as an sample input, and we are calling the rotate array. So in this rotate array, what we expect is, so we expect to move the last element by once, or the rightmost element need to be moved once. And when we do a sample output, we are doing it sample output. That's the expected is 5, 1 and 2, 3, 4 is a sample output here. And this whatever the rotate or whatever this can be achieved in this method rotate array, we'll understand the rotate array what it does. We have an input array which is passing as a parameter, and we are not returning anything because we are in place we are making changes to an array. As already said, so we need to keep a track of the last element because we are uh, before this swap happens, like all the elements from the first to last element need to be swapped in between. So that's the reason we need to keep track of a last element. So we are taking this last index, which is array.length -1, because index is why this -1, because the index starts from 0 and it will be in from the length -1. So that's the reason we are taking the last element as L-1, which is length -1. And how do we fetch last element? So array of the last index. So that's how we keep track of what is exactly the last element. When we do an iteration of the for loop, in each iteration, what we do is we'll start we'll start this loop from the last index. If you see, I'm assigning the last index as a initializer, and then we'll be keeping we'll iterate this array till the very first element. We'll not iterate the first element, but the second element is the last element which we are iterating it. And every iteration we are decrementing it because we are starting from the last and then we are going back to the first element. We'll understand this with an example, and then what we do is, so whatever the previous element, we'll assign it to a current element. That's how we swap from the rightmost element. Let's say we have an array 1, 2, 3, 4, 5. So what we are doing is this is the last element, last index. So let's say the 1, 2, 3, 4. The 4 is an index. So we are taking the last index and the last element as a 5, and we are saving it here. Let's say the last element is 5. We have stored it in a variable. And when we start iterating from the last index, so the I will be last index, which is 5. What we are doing is we are taking the previous element, which is I-1 is the third element, meaning third index. So the last index 4 will be swapped to this element. I mean the 4 will be modified here. And then when we decrement this I, so the I will be pointed here. So right now this element is still 4, but we don't have to worry about that because we'll be moving this 3 to the third index. Then what it happens is 1, 2, 3, 3 and 4. This is what it happens. And when I moves to an again decrement to a next element, which is this element, which is second index, Then what we does is, this is a previous element, the 2 is a previous element. We'll move this 2 to the second index. Then the value will be 1, 2, 2, 3, 4, and then the I will be again, it will be moved here. This last element, which is the 0th index, it will be moved to the first index. So then the array looks like 1, 1, 2, 3, 4, and then because we are looking for the condition I greater than 0, when the I moves to an or decrements to an 0th index, so this condition will not satisfy. So when we will stop moving from the previous element. So then the final array will look like this: 1, 1, 2, 3, 4, and whatever the last element which we have captured here, the last element, what we do is we'll assign it to a 0th index, and then the solution will be 5, 1, 2, 3, and 4. If you look at this an array, this is what the expected output is. So this is how we achieve from this code. Now let's understand then the time complexity of this solution. As we are iterating the n minus 1 elements, so we can consider the time complexity will be big O of n, and the space complexity will be, we are not using any extra spaces, so that's the reason we can consider it as a constant space. We can consider this as a constant space. So this is all fine. So because we are moving only one element, we are rotating only one element. So what if we wanted to rotate the n number, meaning whenever they send any t or n, we need to rotate that many number of elements need to be rotated. So how do we achieve that? There is an video upcoming. There is a part 2 for this same problem. In that problem, we'll be solving that. Thank you for watching. Please share, subscribe. Thank you.